Assalamualaikum and hi. So this is the frequency response design using likely compensator using Matlab. So we continue and on step 3. So for step 3, based on the transfer function in S domain, we determine the transfer function in frequency domain by replacing S with j omega and then construct the bot table and next draw the bot plot. In Matlab, we just use this coding bot for G. So we do not need to do this step replacing S with j omega. We're using the bot plot. It will use this transfer function in frequency domain, and this is the bot plot for magnitude and phase for this transfer function G. So the starting point is at 0.1 radian per second is 68.1 dB. Okay, and then the next step is step 4. We determine the required phase, which is the desired phase margin from damping ratio. This one is equal to this one, this formula, at tangent to zeta divided by square root of this function. So we need to write the actual formula based on this one in the Matlab coding. So arctangent is using this label, this coding A tan. Okay, the rest is equal to this one. But for Matlab, we need to convert this radian value of angle to degree by using this equation 180 divided by pi. So I label this required phase as PM required. In my case, my PM required is 53.17 degree. And then in step 5, I determine the omega PM prime equal to 0.8 required bandwidth frequency. So I use the same formula, and then I determine the omega PM prime. In this case, the omega PM prime is 12.2572 radian per second. And then in step 6, I need to refer to my bot plot on phase to determine this value. In my case, at 12.3 radian per second, my omega PM prime, the phase is negative 138, and then I determine PM, and the next one I determine P max. Okay, in my case, my PM is 42, this one, PM is 42, and then my P max is 21.1163. Okay, this one. So my phi max is 21.1163. My PM at omega PM prime is 42.0555. This one is based on the value of phase at omega PM prime 12.2572. Okay, so we continue step 7 in the next video. Thank you.